Solubility of ionic compounds and इसके examples किए थे हमने last. ठीक है, let us continue beyond that. It is chemical bonding, lecture 3. We'll learn about Born-Haber cycle today. Born-Haber cycle is used to measure the kinetic lattice energy. It is used to measure the lattice energy of ionic compounds. It is a thermodynamic cycle, which represents the formation of ionic compounds in different steps. It is a thermodynamic cycle that represents the formation of ionic compounds in different steps. एक मिनट रुकना. It is a thermodynamic cycle that represents the formation of ionic compounds in different steps. Compounds in different steps. एक examples explain करता हूँ. Let us consider the formation of sodium chloride. Sodium chloride may be assumed to be formed by reacting sodium and chlorine. We'll write a balanced reaction for formation of 1 mole of sodium chloride. Okay, the enthalpy change for the reaction is often called as enthalpy of formation or heat of formation. Okay, and this enthalpy of formation or heat of formation can be represented in multiple steps. Delta HF is called enthalpy of formation. It is the change in enthalpy when 1 mole of any compound is formed from its elements in their natural state. ठीक है, तो सोडियम क्लोराइड का अगर एंथैल्पी ऑफ फॉर्मेशन रिप्रेजेंट करेंगे, सोडियम नेचुरल स्टेट इज Na solid, chlorine natural state is chlorine gaseous. ठीक है, so we have to represent formation of sodium chloride from sodium and chlorine in their natural states. The natural state of sodium is sodium solid, natural state of chlorine is chlorine gaseous. ठीक है, we have to represent formation of 1 mole of ionic compound, 1 mole of this compound, and the change in enthalpy during this process will be enthalpy of formation will be denoted by delta HF. ठीक है, इसको मल्टीपल स्टेप्स में रिप्रेजेंट कर सकते हैं. डाउट्स में बताता हूँ, रुक जाओ, डाउट्स लास्ट में करते हैं, लास्ट 10-15 मिनट्स विल डू डाउट्स. तो इसको डिफरेंट स्टेप्स में रिप्रेजेंट करेंगे. तो वन ऑफ द स्टेप टू कन्वर्ट सोडियम will be to convert sodium solid into sodium gaseous. This process will absorb some energy. The energy absorbed for this process will be heat of sublimation, enthalpy of sublimation. Then sodium gaseous will be converted into Na plus gaseous. The energy absorbed for this process will be ionization energy, delta H ionization energy. This is delta H ionization energy. The chlorine gaseous is converted into atomic chlorine. Okay, for this some amount of energy is absorbed to break the chlorine-chlorine bond, which is often called as the bond energy or the bond dissociation energy. Half se multiply kiya because we have half mole of chlorine. Then Cl gaseous is converted into Cl minus gaseous. Some energy will be released in this process, that will be delta HEG. And then gaseous ions will combine to form lattice. Okay, and during this process some energy will be released, that is equal to lattice energy. Last lecture में याद करो हमने Hess law किया था. Total change in enthalpy remains same whether reaction occurs in a single step or in a number of steps. We can say that the total enthalpy of formation of sodium chloride will be equal to sum of the sublimation energy plus ionization energy plus half into the bond energy or the dissociation energy of chlorine-chlorine bond plus delta HEG plus delta HLE. We can represent the enthalpy of formation of the ionic compound in terms of various other thermodynamic parameters. Okay, the various other thermodynamic parameters. Delta sublimation is the sublimation energy. Okay, so we'll complete this definition part. ये सारे parts, सारे terms क्या क्या represent कर रहे हैं ये लिख लो. Delta H sub is representing the sublimation energy. Delta HIE is the ionization energy. Delta HBE is the bond energy or bond dissociation energy. ठीक है, ये नोट कर लो फटाफट. नोट कर लिया? Is this done? बस ये ध्यान रखना कि if ionic compounds are different, for different ionic compounds, the coefficients for sublimation energy, ionization energy, bond energy, etc. may be different. So for example, देखो, let us draw the Born-Haber cycle for, suppose we are drawing the Born-Haber cycle for Al2O3. Okay. So we have to represent formation of Al2O3 solid, 1 mole of Al2O3 solid from its elements in their natural state. Aluminum natural state is solid state. Oxygen natural state is gaseous state. We'll write the reaction as 2Al plus 3/2O2 gaseous, giving Al2O3 solid. The change in enthalpy during this process is enthalpy of formation. We can represent this reaction in multiple steps. Aluminum solid giving aluminum gaseous. This will be twice of delta H sublimation. Then aluminum gaseous into aluminum ions. This will be 2 into delta H IE total लिखेंगे. Total इसे लिखेंगे क्योंकि this will be sum of the first 3 ionization energies. Delta H IE total will be equal to IE1 plus IE2 plus IE3 because we are removing 3 electrons from aluminum to get aluminum 3 plus. Now this 3/2O2, the bonds will be broken to form 3O. This will be 3/2 into delta H bond energy. And this will gain electrons to give oxide anions. This will be 3 into delta H Eg total. Once the gaseous ions are formed, they will combine to form lattice. The energy change in this process will be delta H lattice energy. We can write for aluminum chloride, for aluminum oxide, we can write theta formation is equal to 2 into delta H sublimation plus 2 into delta H IE total. This way, we can draw Born-Haber cycle for any ionic compounds. 3/2 into delta H bond energy plus 3 into delta H Eg total plus delta H lattice energy. आ रहा है समझ में? What kind of questions will be asked from this? Direct questions आएंगे इससे. देखो मैं एक बुकलेट पे क्वेश्चन करा देता हूँ इससे. एक चीज इंपॉर्टेंट है. Generally, in this process, lattice energy will have a negative sign. Sublimation energy, ionization energy will have a positive sign. Bond energy will have a positive sign. Electron gain enthalpy may have a positive or a negative sign, but lattice energy will have a negative sign. क्वेश्चन कर ही लेते हैं इससे. रुक जा, मैं क्वेश्चन देता हूँ इससे. Did I share any assignment of chemical bonding? I did share. Normally values given होंगे. Delta H lattice energy, delta H. मतलब ये जो मैथमेटिकल इक्वेशन लिखा ना हमने, इस इक्वेशन में बाकी सारे वैल्यूज गिवन होंगे, एक वैल्यू अननोन होगा. तो द अननोन वैल्यू कैन बी कैलकुलेटेड फ्रॉम द अदर वैल्यूज गिवन. बुकलेट में वी हैव सम क्वेश्चंस बेस्ड ऑन दिस. एक क्वेश्चन देखो, दिस इज गेट इक्विप्ड टू जेईई मेन का क्वेश्चन नंबर 8 एंड क्वेश्चन नंबर 9. बुकलेट का गेट इक्विप्ड टू जेईई मेन क्वेश्चन नंबर 8 एंड क्वेश्चन नंबर 9. ट्राई करो ये दोनों क्वेश्चंस. Get it to JEE main, question number 8 and question number 9. So question number 8, which change corresponds? So this is a Born-Haber cycle. Okay. So this is the formation of the potassium fluoride solid. ठीक है, इसको एनर्जी डायग्राम में बनाया हुआ है. जो नीचे बना है उसकी एनर्जी कम है, जो ऊपर बना है उसकी एनर्जी ज्यादा है. तो फर्स्ट स्टेप ध्यान से देखो. फर्स्ट स्टेप में potassium solid converts into potassium gaseous, fluorine remains as it is. So first step corresponds to the sublimation energy. ये step 1 is sublimation. ठीक है. Step 2 में देखो fluorine gaseous F2 gaseous converts to F gaseous. So this corresponds to bond energy. The next step is F gaseous to F minus gaseous. Sorry. This next step is fluorine remains as F, but it is the potassium K gaseous converts to K plus gaseous. The next step is ionization. So this is ionization energy. Next step is F gaseous converts into F minus gaseous. So step 4 is electron gain enthalpy. पूछा क्या? Which energy corresponds to electron affinity of fluorine? The fourth. The fourth step is corresponding to electron affinity of fluorine. ठीक है, आ रहा समझ में? Eight का C, yes. Question number 9 देखेंगे, which corresponds to first ionization energy of potassium. It is the step 3 that corresponds to the first ionization energy of potassium. So D. Clear है? नेक्स्ट देखो, एक और क्वेश्चन देखो, उसके नीचे एक और क्वेश्चन है. Using the Born-Haber cycle, heat of formation of KBr is equal to. ठीक है, heat of formation of KBr is equal to. So we can write heat of formation of KBr is equal to delta H sublimation of potassium plus delta H ionization energy of potassium. ठीक है, plus half into delta H bond energy of bromine plus delta H Eg of bromine plus delta H lattice energy. ठीक है, तो अगर इलेक्ट्रॉन एफिनिटी के टर्म्स में लिखेंगे तो इलेक्ट्रॉन एफिनिटी के टर्म्स में डेल्टा H Eg विल बी इक्वल टू माइनस ऑफ Ea ऑफ ब्रोमीन. ठीक है, और अगर मैग्नीट्यूड के टर्म्स में लिखेंगे दिस बिकम्स माइनस ऑफ मॉड ऑफ डेल्टा H Le, क्योंकि डेल्टा H Le हैज अ नेगेटिव साइन. तो यहाँ पे एक्चुअली टर्म्स का मतलब क्लियरली स्पेसिफाइड नहीं है. अनलेस अदरवाइज स्पेसिफाइड हम सब कुछ प्लस के टर्म्स में लिखते हैं, डेल्टा H Eg प्लस डेल्टा H Le लिखते हैं. तो अगर कुछ भी स्पेसिफाइड नहीं है तो विल राइट इट लाइक दिस ओनली. We write it like this, plus delta H Eg plus delta H Le, और फिर लैटिस एनर्जी का वैल्यू नेगेटिव पुट करेंगे. तो एक्चुअली में इट शुड बी, which expression should be there? It should be heat of formation of KBr will be equal to heat of formation of potassium gaseous plus heat of formation of bromine gaseous plus ionization energy of potassium plus electron affinity of bromine. एक्चुअली इस क्वेश्चन थोड़ा सा इनकम्प्लीट है, मैं इस क्वेश्चन को थोड़ा सा करेक्ट कर देता हूँ ताकि आंसर सही मैच हो जाए. इस क्वेश्चन में एक चीज ये लिख लो कि डेल्टा H लैटिस इज द मैग्नीट्यूड ऑफ लैटिस एनर्जी. डेल्टा H लैटिस is the magnitude only, then it will become negative of EBr and negative of lattice plus of ionization energy. तो कौन सा ऑप्शन मैच करेगा? आई थिंक इसमें से तो कोई भी ऑप्शन मैच नहीं कर रहा है. रुको एक सेकेंड. ठीक है, मैग्नीट्यूड वाइज एक भी ऑप्शन मैच नहीं कर रहा है, तो बेस्ट ऑप्शन हम मार्क करेंगे. बेस्ट ऑप्शन विल मार्क इट एज ए ऑप्शन. ठीक है, मोस्ट अप्रोप्रिएट आंसर विल बी ए. ठीक है, डेफिनेटली इसका वैल्यू नेगेटिव आएगा. और इसका भी वैल्यू नेगेटिव आएगा। ठीक है, इसका आंसर में मिस्टेक है, ये करेक्शन कर लेना, क्वेश्चन नंबर 12। ठीक है, तो कंसेप्चुअली हम बॉर्न नेबर साइकिल जब भी अप्लाई करते हैं तो सारे डेल्टा एच वैल्यूज एज इट इज ऐड कर देते हैं। ठीक है, इट्स डेल्टा एच एलई दैट विल हैव अ नेगेटिव साइन एंड डेल्टा एच ईजी मे बी हैविंग अ पॉजिटिव और अ नेगेटिव वैल्यू। ठीक है, बाकी सब पॉजिटिव आएगा। डेल्टा एच सब्लिमेशन इज पॉजिटिव, डेल्टा एच आयनाइजेशन इज पॉजिटिव, ठीक है, द बॉन्ड एनर्जी इज पॉजिटिव। यहाँ पे ध्यान से देखना, ये के सॉलिड टू के गैसियस, इसको हम हीट ऑफ फॉर्मेशन ऑफ के गैसियस भी लिख सकते हैं। इन्होंने सब्लिमेशन एनर्जी की जगह ये वाला टर्म यूज किया है, के सॉलिड टू के गैसियस को सिंपली इन्होंने हीट ऑफ फॉर्मेशन ऑफ के गैसियस लिखा है। ठीक है, सिमिलरली ब्रोमीन गैसियस टू या ब्रोमीन लिक्विड टू ब्रोमीन गैसियस, इसको इन्होंने हीट ऑफ फॉर्मेशन ऑफ ब्रोमीन गैसियस डायरेक्ट लिख किया है। ठीक है, ऐसे नोटेशंस भी यूज कर सकते हैं। ठीक है, आ रहा है समझ में? Now let us continue with this. Next topic we'll study is Pajan's rule. We'll talk about covalent character in ionic compounds. Okay. Every covalent bond can have some degree of ionic character in it. Every ionic bond can have some degree of covalent character in its bond. So you can write no bond between two different elements is 100% ionic or 100% covalent. A covalent bond has ionic character due to the electronegativity difference of the bonded atoms. ठीक है, और परसेंटेज आयनिक कैरेक्टर का एक फॉर्मूला हमने पीरियोडिक टेबल में किया ही था, याद करो। परसेंटेज आयनिक कैरेक्टर इज 16 into डेल्टा एक्स प्लस 3.5 into डेल्टा एक्स का होल स्क्वायर। ये फॉर्मूला हमने पीरियोडिक टेबल में किया था। So more is the difference in electronegativities, more is the ionic character. Similarly, an ionic bond can also have some covalent character, and the extent of covalent character in an ionic compound is given by a set of rules known as Pajan's rules. Okay? So the extent of covalent character in ionic compound is given by Pajan's rules. Now let us understand the origin of covalent character in ionic compound. How does an ionic compound get some covalent character? Thinking of a cation and anion present adjacent to each other. Generally, cations are smaller in size and anions are larger in size. Generally, cation is smaller and anion is larger. तो anion में भी एक पॉजिटिव न्यूक्लियस है और न्यूक्लियस के चारों तरफ उसका इलेक्ट्रॉन क्लाउड है. So we are representing the spherical electron cloud of the anion. When they are present very close to each other, the positive charge of the cation repels away the nucleus of the anion and attracts the electrons of the anion. So we can say that the positive charge of cation causes a distortion in the anion. How will it cause a distortion? It will attract the electrons towards itself. It will repel the nucleus away from itself. It results in a distortion of the anion. ठीक है? कैसा डिस्टॉर्शन होगा मैं देखो नेक्स्ट पेज में एक्सप्लेन करता हूँ. The cation will attract the electron cloud towards itself and it will repel away the nucleus. The distortion results in the shift of electron density. The electron density shifts towards the cation. This is the cation. This is the distorted anion. So due to the electrostatic force of attraction from the cation, the anion undergoes distortion. Okay. This distortion of anion by the attraction of the cation is called the polarization. It's very important here. This distortion of anion by the cation is called polarization. Broadly speaking, polarization is redistribution of electron density. एक सेकंड रुकना. In a molecule or an atom or any ion. This is the broader definition of polarization. In terms of ionic compounds, it is generally the anion that is polarized by the cation. Polarization of cation by anion is negligible. We generally ignore it. Okay? ये point भी लिख सकते हैं. In ionic compounds, it is the anion that is polarized by the cation. Cation by anion is negligible. ठीक है, आ रहा है समझ में ये पॉइंट? Now once we have understood the polarization, polarization समझ रहे हैं polarization क्या है? Okay. What is polarization? Polarization is the distortion of electron cloud of an ion by the cation. And during this polarization, the electron density shifts towards the cation. इस तरह से electrons get shared between the cation and anion. The electrons of the anion, the electron cloud of the anion is shifted towards the cation. So due to polarization, electron density gets shared between the cation and anion. Okay. And sharing of electrons results in a covalent bond. So we say that due to polarization, of an ion, electron density of the anion shifts towards the cation, resulting in sharing of electron density between the two ions. To some extent, between the two ions, resulting in some covalent character. So thus, we say that more is the polarization of the anion, more is the covalent character in the ionic compound. Okay, so it is the polarization of the anion, it results in some covalent character in the ionic compound. More is the polarization of the anion, more will be the covalent character in the ionic compound. आ रहा समझ में? So we can write this point. More is the polarization of an ion. Or is the covalent character in ionic compounds. The extent of covalent character depends on the extent of polarization. यहाँ पे different factors को हम ऐसे summarize करेंगे. इसमें first point हम लिखते हैं, we'll talk about polarizing power of cation. It is a measure of the ability of cation to polarize the anion. It is a measure of the ability of cation to polarize the anion. This polarizing power is directly proportional to the magnitude of charge. Is proportional to the charge on the cation. Is inversely proportional to the size. It is inversely proportional to the radius of the cation. And then another point we compare is polarizability of an ion. It is the ability of an anion to undergo polarization. It is the ability of an ion to undergo polarization. Okay. Polarizability is directly proportional to the magnitude of charge. जितना ज़्यादा charge होगा, ठीक है, electron density जितनी ज़्यादा होगी, electron cloud जितना बड़ा होगा, ठीक है, polarizability उतनी ज़्यादा होगी. It's directly proportional to charge, and it is directly proportional to size of the anion. Larger anion, okay, its electrons are away from its nucleus. These electrons are more strongly attracted by the cation. These electrons can be more easily polarized. Polarizability of an ion depends on the charge. Polarizability depends on the size. Okay. For any molecule, the polarizability will depend on its size. For any atom, polarizability will depend on size. A larger atom, a larger molecule, a larger ion is more easily polarized. इसीलिए हम generally cation का polarization ignore करते हैं because cation is smaller in size and anion is larger in size. Okay, so we can say that larger atom or molecule or ion has greater polarizability. ठीक है, आ रहा है समझ में? Next देखो, we'll talk about the factors affecting covalent character. Bigger is the ion, more is the polarizability. Yes, it is more polarizable. Factors affecting the extent of covalent character in ionic compounds. These factors are often called as the Fajan's rules. इसमें first point लिखेंगे, the covalent character is directly proportional to the charge on the cation. The covalent character is directly proportional to the charge on the anion. The covalent character is inversely proportional to size of the cation. The covalent character is directly proportional to the size of the anion. Okay. And another important point is, the point लिख लो, explain करता हूं मैं. Cations with pseudo inert gas configuration. Pseudo inert gas configuration bracket में लिख लो NS2 NP6 ND10 have higher polarizing powers than cations with inert gas configuration. Inert gas configuration bracket में NS2 NP6 of comparable sizes. Pseudo inert gas configuration and inert gas configuration. ये एक बार explain कर देता हूं मैं. Examples of cations with pseudo inert gas configuration: copper, zinc, silver, gold. एक second. Zinc, cadmium, mercury, gallium, indium, thallium. Copper +1, Ag +1, gold +1, zinc +2, cadmium +2, mercury +2, gallium +3, indium +3, thallium +3. Okay. If you look at their outermost subshell electronic configuration, ठीक है, इसके लिए outermost electronic configuration आएगा 3s2, 3p6, 3d10. इसके लिए आएगा 4s2, 4p6, 4d10. और इसके लिए आएगा 5s2, 5p6, 5d10. So these cations have a fully filled d subshell in addition to a noble gas core. इसको अगर generalize करेंगे तो this is argon 3d10, this is krypton 3d10, 4d10, and so on. So they have a fully filled d subshell in addition to the noble gas core. So this results in a d subshell. D subshell electrons have poor shielding. Okay. D and F electrons have poor shielding. So D electrons have poor shielding. Due to poor shielding, the nuclear charge is high. Here, poor shielding results in high effective nuclear charge. High effective nuclear charge results in high polarizing power. So generally, these cations result in a higher polarizing power. Okay. These are the cations with pseudo noble gas configuration: copper +1, silver +1, gold +1, zinc +2, cadmium +2, mercury +2, gallium +3, indium +3, thallium +3. So these cations, these are some of the cations with pseudo noble gas configuration, and these cations generally have higher polarizing power than the cations with noble gas configuration. Cations with noble gas configuration such as Na+, Mg2+, Al3+. These are cations with noble gas configuration. Okay? So this rule can be further generalized. A copper, zinc, cadmium, mercury, these are D block metals. Indium, thallium are P block. So generally, we can further generalize this rule. In general, we'll write this point. The cations belonging to D block and P block. The cations of P block and D block metals have higher polarizing powers than cations of S block, resulting in greater covalent character in their greater covalent character in ionic compounds of D block and P block metal ions. Okay. The reason is the presence of partially or fully filled D subshell, okay, whose electrons have poor shielding, and poor shielding results in higher effective nuclear charge. Higher effective nuclear charge will result in more polarizing power. Pseudo inert and inert gas configuration. चलो मैं और अच्छे से explain करता हूँ, अभी भी doubt है. Let us consider the magnesium ion, magnesium 2+. ठीक है, हाँ एक सेकेंड. मैग्नीशियम 2+, मैग्नीशियम एटम का कॉन्फ़िगरेशन पहले लिखते हैं. मैग्नीशियम इज 1s2 2s2 2p6 3s2. So magnesium 2+ is 1s2 2s2 2p6. So outermost shell is ns2 np6. So this is noble gas configuration, inert gas configuration. Now let us think of zinc. Zinc is 1s2 2s2 2p6 3s2 3p6 4s2 and 3d10. This is zinc. Zinc 2+ will become 1s2 2s2 2p6 3s2 3p6 and 3d10. 4s is 0. This is the outermost shell configuration. This is effectively ns2 np6 and nd10 for the outermost shell. This is called the pseudo inert gas configuration. आ रहा है समझ में विरोक? Three S2 3p6 3d10. ठीक है, एक बार ये प्रीवियस स्लाइड नोट कर लो. ये भी जल्दी से नोट करो. Now we can do some examples. You can compare covalent character in some ionic compounds. So example देखो, comparing covalent character in NaCl, MgCl2, AlCl3. But the straightforward comparison है, as the charge increases, the covalent character will increase. Na+1, Mg+2, Aluminium+3. More is the charge on the ions, more is the covalent character. So in fact, SiCl4 is a covalent compound. AlCl3 also has a significant covalent character. NaCl and MgCl2 are ionic compounds. AlCl3 is quite unique. Anhydrous AlCl3 is found to be covalent. Is a covalent compound. Hydrated AlCl3 is an ionic compound. AlCl3 is found to exist as ionic as well as covalent compound. Aluminium chloride. Okay. So from sodium chloride to magnesium chloride to aluminium chloride to silicon chloride, okay, the percentage, the extent of covalent character in the compounds increase. Okay, more is the charge on the cations, more is the covalent character. Aluminium chloride is found to exist in ionic as well as covalent forms. Anhydrous aluminium chloride is found to be a covalent solid, whereas hydrated aluminium chloride is found to be an ionic solid. Okay, clear है ये? As charge on the cation will increase, covalent character will increase. Turn करूँ page. AlCl3 is not a liquid. Okay. Anhydrous aluminium chloride is also a solid. Hydrated aluminium chloride is also a solid. In the anhydrous form, it is found to have a covalent structure. We have AlCl3 molecules. In the hydrated form, it is found to have an ionic structure where it is consisting of aluminium ions and chloride ions. ठीक है? Some more examples of comparing covalent characters. Li2CO3, Na2CO3, K2CO3, Rb2CO3, CS2CO3. ध्यान से देखना. As the size of cation decreases, covalent character increases. Smaller cation will result in more polarizing power, more covalent character. So lithium carbonate will have greater covalent character than sodium, then potassium, then rubidium, then cesium carbonate. As the size of an ion increases, covalent character increases. Lithium fluoride, lithium chloride, lithium bromide, and lithium iodide. The covalent character increases with increase in size of the anion. It is the iodide which will be more covalent than bromide, then chloride, then fluoride. Comparing between an ionic compound of an S block metal and an ionic compound of a P block metal, MgCl2, PbCl2, which is more covalent? PbCl2 is more covalent. Okay, the P block cation will have more polarizing power than the S block cation. आ रहा है समझ में? As the size of an ion increases, covalent character increases. As the size of cation decreases, covalent character increases. So these are, okay, orders of covalent character in some ionic compounds. AgF, AgCl, AgBr, AgI. Okay, as the size of an anion increases, covalent character increases. These are different examples. आ रहा है समझ में ये? Now we'll do some applications of Pajan's rules. इसमें एक पॉइंट लिखेंगे कलर ड्यू टू पोलराइजेशन, काफी इंपॉर्टेंट पॉइंट है. Many ionic compounds are colored due to polarization. What happens? Polarization of an ion excites the electrons. Polarization of an ion excites its electrons, which on de-excitation may emit radiations in the visible range, resulting in characteristic colors. May emit radiations in the visible range. Resulting in characteristic colors. Okay. So therefore we say that the more polarizable an ion has greater tendency to form colored compounds than the less polarizable an ion. Okay. Therefore, more polarizable anions have greater tendency to form colored compounds. ये नोट कर लो, मैं नेक्स्ट पेज में एग्जांपल सिखाता हूँ. तो पोलराइजेशन से क्या हो रहा है? इलेक्ट्रॉन्स आर पुल्ड अवे फ्रॉम द न्यूक्लियस. The electrons are excited to high energy levels. These excited electrons, on de-excitation, they may fall back to low energy levels and emit some radiations. And these radiations may be in the visible range. Okay. And such a process is more likely to occur if the polarization is more. Extent of polarization is more, is generally in the larger anions. It is found that many iodides of mainly the P block and D block metal ions are colored, whereas iodides of S block metal ions are not colored, because S block metal ions do not result in significant polarization. It is the P block and D block metal ions that result in a significant polarization. So many iodides of the P block and D block metal ions show characteristic colors, but the chlorides, corresponding chlorides, do not show characteristic colors. Bromides may or may not be colored. So tendency to get polarized increases from chloride to bromide to iodide. Iodide show maximum polarization. It is the iodide that show characteristic colors. Okay. Bromides may or may not be colored. Chlorides generally are white or colorless. We'll write this point. Iodides of D block and P block metal ions are often colored, whereas chlorides are white or colorless. एग्जैक्ट कलर तो प्रेडिक्ट नहीं कर सकते, बट कलर्ड होगा कि नहीं वी कैन से अबाउट इट. जैसे आयोडाइड्स of P block and D block metal ion. Silver iodide is bright yellow in color. Even silver bromide is pale yellow. तो bromides में उतनी कलर नहीं आती, but still bromides में also show some colors. But chloride is white. Similarly, mercuric iodide HgI2 is bright red in color, scarlet red बोलते हैं इसको. Whereas HgCl2 is white. Iodides are almost invariably colored. Lead iodide is also yellow in color. Lead chloride is white. आ रहा समझ में? So color in all these compounds is due to polarization. An important point to note here is color may be due to cation only. Color may be due to anion only. Or anion only. Or due to interaction between cation and anion. ठीक है, एग्जाम्पल देखो. FeSO4, FeCl2 both are green. So color is due to Fe2 plus, which is green in color. ठीक है. Na2Cr2O7, K2Cr2O7 both are orange. Color is due to the dichromate anion Cr2O72 minus ion. ठीक है. पर ध्यान से देखो, sodium iodide is white, sodium chloride is also white, but silver iodide is yellow. तो सिल्वर आयोडाइड का कलर इज नॉट बिकॉज ऑफ सिल्वर. अगर सिल्वर की वजह से कलर आता तो सिल्वर क्लोराइड भी येलो कलर का आना चाहिए. सिल्वर आयोडाइड का कलर इज नॉट बिकॉज ऑफ आयोडीन, क्योंकि अगर सिल्वर आयोडाइड व्हाइट है, येलो है आयोडीन की वजह से, तो सोडियम आयोडाइड भी येलो आना चाहिए था. तो कलर इन सिल्वर आयोडाइड इज नॉट बिकॉज ऑफ द सिल्वर आयन और बिकॉज ऑफ द आयोडाइड आयन, but it is because of polarization of iodide ion by the silver ion. ठीक है. This color is not due to either Ag plus or I minus only, but due to the interaction between Ag plus and I minus. आ रहा है समझ में? तो होमवर्क में असाइनमेंट 1.1 टू 1.11 करना है. एक्सरसाइज 1 1.11 1.1 टू 1.11 ये होमवर्क है. बुकलेट से भी होमवर्क दे रहा हूं मैं. बुकलेट में FBO क्वेश्चन नंबर 1 to 5. So exercise 1, 1.1 to 1.111 और FBO क्वेश्चन नंबर 1 to 5. ठीक है. विरोक तेरे डाउट्स कर लेता हूं मैं अभी. हाँ, पीरियोडिक टेबल के असाइनमेंट में तेरे डाउट्स है. आदर्श में ली विरोक के डाउट्स मैं कर लेता हूं अभी. चलो, थैंक यू एंड टेक केयर, हैव अ गुड डे. तब तक मैं विरोक का डाउट्स कर लेता हूँ. विरोक तो रुक जा. इफ एनीवन वांट्स टू लीव यू मे लीव. बोल विरोक, क्या डाउट्स है तुझे? यू मे अनम्यूट.
Sir, am I audible?
Yes, yes, you're audible.
Sir, exercise 1, question number 5.
1 second, let me open it. इधर ही ओपन करूं? रुक, इधर ही करता. ये नोट कर लिया ना?
हाँ, yes sir.
Which shows maximum radius. This is based on the charge on the atom. More is the positive charge, smaller will be the radius. This is manganese plus 4, this is manganese plus 7, this is manganese plus 2, this is manganese plus 3.
Option C.
More charge means smaller radius. Okay?
Okay,
The smallest radius will be KMnO4 and largest radius will be MnO.
Okay, sir. And
Understood?
yes, sir, understood. Sir, and question number 40 of this exercise only.
In which of the following process energy is liberated?
Sir, no,
So,
no. I think this was not the doubt. Sir, I think this I had cleared. I had another question. I had marked it. Just a minute, sir.
No problem. Is this one the doubt?
No, not of the second exercise also.
Okay, fine. Check.
I have marked. Okay, only question number 5 and 40. Question number 5.
Question number 5 we did.
Only question number 5 was. Question number 40 was cleared. Clear.
Okay, fine. Okay?
Yes, sir. Thank you.
Thank you. Thank you, everyone. Ending the lecture.